Today we are going to implement a MinHeap class such that given a array, then we create the MinHeap by the time complexity O(n). Normally we know that if we want to use a periodic queue, when we traverse a given array, and insert every element in this array into periodic queue, the total complexity will be O(n) log n. Let me explain why this method will create this. The time complexity will be O(n) to create this MinHeap. This is the given array. There are 9 numbers here. So because we know the periodic queue is a completed binary tree. So according to this given array, then we can create the periodic queue heap like this, and we need to traverse all the parents nodes and compare to its child nodes. Then if the parent node value is bigger than the child nodes, we need to swap the parent node with its child node to finish this percolate down method. For example, in this periodic queue, the last parent node is 2. We compare with its child node 13 and 3. 2 is smaller than its child node, so we don't move this parent node. The next one is a parent node is 7. 7 is bigger than 4 and 6 child node. We need to swap a parent node with its smallest child node here. So smallest one is 4. So the 4 will be here, and 7 will be here. The next one is 11. 11 we compare 11 with child nodes and swap with its smallest child node here. So the 11 will be here, and the 2 move to here. We still need to compare 11 with a new child nodes 13 and 3, and we swap 3 and 11. The next parent node is 10. We compare with its compare 10 with its child node 2 and 4, and swap 10 with its smallest child node here. So and compare 10 with its new child nodes 3 and 8, and swap with the smallest child node, and we move 10 here and 3 here, and we compare 10 with its new child nodes 13 and 11. So we don't move 10. Now we finish this percolate down. Let's calculate the time complexity here. The first level, if we want to finish the percolate down, the first level, the total nodes in this level is 2 to the power of 0, and it will compare the rest level total. So the total number of comparing is k minus 1, plus the next level is total nodes will be 2 to the power of 1, and in this level the compare times will be k minus 2. The next level is 2 to the power of 2, and the total the number amount of comparison will be k minus 3, and the last level is this level. We don't compare the last level, because this level is the last level. So we only the last level we need to do is the this level here. the total nodes here is 2 to the power of the last level. The power of the total nodes will be 2 to the power of k minus 1 because this level is k minus 1 level. So the previous level total nodes amount will be 2 to the power of k minus 2, only multiplied by 1 times this is only this level, this node in this level only need to be compared 1 times. We multiply by 2 this equation, then it will be this item multiplied by 2 is 2 to the power of 1 multiplied by k minus 1. And this item 2 will be up after multiplying by 2 is 2 to the power of 2 multiplied k minus 2. And the last level is this level. It will be 2 to the power of 2 to the power of k minus 1 multiplied by 1. So if we use 2 sk minus sk is, if this item minus this item, because we're left first we minus the 2 to the power of 0 is 1. So after this item minus this item is minus k minus 1 here, plus this item minus this item will left 2 to the power of 1. This will only 1 left, so this result will be 2 to the power of 1, and this one is 2 to the power of 2. And because this last item will minus 0 here, so the last item will be 2 to the power of k minus 1. This is this is the a geometric sequence. So we use sum of geometric sequence here. Is the first item is 2 multiplied by the 1 minus the common ratio is 2. 2 to the power of, so the total item from 1 to k minus 1 is k minus 1. The total amount of atom is 2 minus 1 here, and multiplied by 1 minus 2. This will be 2 plus 2 multiplied by 2 power of 2 to the power of k minus 1 minus 1 here. So this will be 2 to the power of k minus 2. And this one minus this atom minus this atom will be 2 to the power of k minus 1. So in this equation, we can see k as log n. So the Sn here, the total, the final equation will be n minus log n minus 1. In this equation, n will dominate this equation. So because the one n growing, the n grows much faster than log n, so this total complexity will be O n log O n. This is percolate down method. If we implement the percolate up method, it will a little bit different from this method, and the time complexity also will different. So the this is percolate down. The percolate up method, the time complexity is, if we want to calculate this time complexity, is sk equals every node we need to compare to its parent node. So if we start from this top level, in this level there are 2 to the power of 0 multiplied by 0, because in this level there's no node will be compared to this level, and plus this level there are totally 2 to the power of 1 nodes, and multiply by 1 because only compare 1 times, and the next level is 2 to the power of 2 compares multiply by 2 because this level will compare two times with its parent level, and plus the last level will be this level. The total nodes in this level is 2 to the power of k minus 1 multiplied by totally will compare every node will compare k minus 1 times with its parent node. So this is k minus 1. We can calculate multiply by 2. Then we can change this method to here. The after multiply by 2, this item will be 2 to the power of 1 multiplied by 0, and this item multiplied by 2 will be 2 to the power of 2 multiplied by 1, and the item previous this item is 2 to the power of k minus 2 after compared after multiplied by 2 will be 2 to the power of k minus 1. This is multiplied by k minus 1. This comes from the item previous this item multiplied by 2, and the last item is this one multiplied by 2 will be 2 to the power of k multiplied by k minus 1. Now with 2 sk multiplied by minus sk here, it will be this is 0, and this is also 0. So start from here, this item minus this item will be minus 2 to the power of 1 plus this is also minus because this will left minus 2 to the power of 2, and minus The next one 2 to the power of 3, and this one is 2 to the power of k minus 1. Actually, all of the item will be minus. Then minus. This is plus, because this one will plus there minus 0, still 2 power of k multiplied by k minus 1 here. This is also an geometric sequence, start from minus 2 to minus 2 multiplied by to minus 2 to the power of k minus 1 here. So this equation we can calculate as like the first item is minus 2 multiply 1 minus the common ratio is 2 here, and the total amount is 1 to 1 from 1 to k minus 1. So this total amount is k minus 1 divided by 1 minus the common ratio here equals 2 multiplied by 1 minus 2 to the power of k minus 1 equals 2 minus 2 to the power of k. So this is the final result according to this equation. Now we substitute this equation here, will equals k multiplied by 2 to the power of k minus 2 to the power of k minus 2 to the power of k minus plus 2. If we see this k as a log n, it can be equals to n log n minus 2 multiplied by n plus 2. In this equation, the n log n will domain this equation. So this final total time capacity will be O n log n. So let's finish this class, MinHeap class. and there's array. We use array to finish this, to implement this MinHeap. This is constructor. We initialize this array with the size cap. We now we implement the percolate down method. Because we want to know this current index, if there is child nodes. So here we need to know that the last parent node. How to know this index, the last parent node in this array. If the array's length equals n, the last child node, the last parent node is 2n divided by 2 minus 1. And according to the ith node, the left child node is 2 multiplied by I plus 1. And the right child node is 2 multiplied by I plus 2. This is a formula to calculate the child node and parent node. The ith node, parent node, is I minus 1 divided by 2. This is the formula we calculate to finish this percolate down. Well, this index is larger than no, is smaller than the last parent node. This n is size. It means in this index, there is the number of this index has a child node. In this case, we calculate the left node. The left child node is the current index is 2 multiplied by current index and plus 1. And the right node is 2 multiplied by index plus 2. And because we want to know how to, because we want to know which one is smallest node, so let's first initialize a candidate node here. First equals to the left one, and if the right child node smaller than the left one. Candidate will be equals to right. And then the next step, we need to see if it's necessary to swap. If array index is bigger than array candidate, in this case, we swap index and candidate. Or break, we don't swap parents node and its child nodes. And now, after swap, we change the index to candidate. This is a percolate down method.